In this video, I'd like to show you how to create a binary classification model that we can use it to predict a future movie reviews sentiment, whether it's positive or negative. Let's first go to the root folder of this Django project. As you can see, I already activated the virtual environment. If you have not, you should first activate your virtual environment. And now let's go to this modeling app we just created folder and launch Python console. So to save you some time, I'm just going to copy and paste some code. What it does is import several machine learning libraries from Scikit, and specifically we're going to use pipeline to build a machine learning training pipeline, and we're going to use grid search to find the parameters on a high dimensional grid, specifically the values that corresponding to the best parameters, where we can save the model with best parameter values. And we're also going to use linear SVC, which stands for linear support vector machine. And based on stochastic gradient descent solver. So after loading those libraries, let's load the data first. So as you can see here, I have 2,000 samples that I've loaded to memory. The next step, which is very important in any machine learning practice, is to separate the training data and testing data randomly so that your model will not overfit. Now let's build a machine learning training pipeline. So Scikit has a great pipeline builder. So pipeline is a class, and in this pipeline constructor, I can tell the machine learning training pipeline of what kind of parameters I want to use. And in this case, I want to use a TF-IDF vectorizer. TF-IDF represents for term frequency and inverse document frequency. It's a very common algorithm that in text mining, so that you can find a certain importance of a certain keyword or phrases to a certain document. For example, I have this keyword called happy, and TF-IDF is gonna first compute how many times happy has appeared in this document, and in this case a specific movie review, and then multiply by the inverse document frequency of how frequently happy has appeared in the corpus of the document to try to penalize the most frequent occurred keywords. So it's kind of a trade-off and a balance. Imagine that you have a lot of stop words like there, and there appears a lot in any document, but it also appeared in a majority of the documents in the corpus. So that it could, using this formula, you can try to think about a good balance that represents the importance of certain keyword to a document. And min df represent minimum document frequency, which means that for any keyword or any phrases in any movie reviews that we loaded, we'll only consider the any word that appears in at least 3 documents. So that for a document that is so obscure that it only appears in 2 documents or less, or 1 document, we won't consider that and convert that into a column in our to fit into a machine learning model. And max df represents the maximum threshold of any keyword of word phrases in the entire corpus. so that for a keyword like the, a, and for those stop words, there appears too frequently that 95% of the 2,000 samples contain this keyword, then we won't use it to construct our features either. And the next CLF represent classifier. Here we're using linear support vector machine to create this machine model. And capital C equals 1 is a regularization parameter. C equals 1 is a default. In this case, we can try to play with, if you have time or interest, you can try to play different value of C and see how that performs better in terms of model performance. So after set up this pipeline, what we need is tell the machine learning model or pipeline what kind of parameters we want to use in terms of searching for the best parameters. In here, I'm trying to play different types of n-grams. N-grams means that, so 1, 1 means I want to select one word and one word only. And for 1 and 2 represent, I want to build a model based on features constructed from one continuous word plus as well as 2 words that are continuous together. So 1, 3 represent I want to use one single word, 2 words, and 3 continuous words to construct my feature lists. And now we're going to use in grid search to find out what are the best parameters. And in here, the only parameters we're playing with is n-gram, what the n should be. So I run this grid search.fit and try to find out what kind of parameters I can use in terms of searching for the n-grams parameters space, so that it gives me the best or give me some the values of each individual n-gram values. So here I should have 3 results, 3 models that using 1 gram, which is 1 word only, to construct my features, and background, which contains 1 word plus any 2 continuous words, and then trigram, which contains 1 word, two words, as well as 3 continuous words. So let's see what the best parameters of the best model look like. In here, what I can do is inside of this grid search class, there is a class property, a class member called best __. So let's see. Oh, in here, I found out what's the best score on my training data, and it turns out I have the best score of about 86% accuracy. And then what are the parameters that corresponding to this model? I can do is that I can find the parameters in the keys and can print them out. So it turns out that bigram actually has the best result. So next, I wanted to save this model with the best parameters after this grid search. And what I can do here is in scikit-learn, there's a library called joblib, but in newer scikit-learn libraries, it's no longer available inside of this library. So joblib is going to be in directly from joblib. So if you're using scikit-learn, some newest version of scikit-learn, you probably will see this warning. And if you're using scikit-learn version 0.23 or even newer, then you should import joblib from joblib library directly instead of from scikit-learn, the external libraries. So in here, I want to save this model and its parameters into a binary file on my local computer, and I want to call it model.file. So After this, I'm calling this binary file model to file so that in the future I can load this binary file into memory and keep using this model. So I no longer have to retrain the model. I just want to use this best model to serve any future incoming samples and make a prediction. So that's what this job does. And also, I want to show you another cool things about using this model. So, for example, I want to see what the how this model performs in the testing data, which is like a quarter of the samples that we separated from the training data. So what we can do here is call this best model that I saved here from the best estimator get params. And then there's a built-in function called predict. And I'm feeding the test documents here. And another very cool thing that I want to point out is that actually the model knows how to process the text files directly. We don't need to create or convert those texts into vectors or numerical vectors. We can just use best model predict, and this function knows how to pre-process all those text samples directly. We don't have to convert them. So as you can see here, docs tests are just pure text is actually an array of about 500 samples, which is very cool. Saves a lot of time for you to process this test data, feed into them, and this model again. Now, let's see what the results look like. Making a prediction on the test results, and save the results into y-hat test, and then I'm calling a Scikit learn function called confusion matrix, and I'm creating this confusion matrix so that each row is a true ground truth. Each column is the actuals. Sorry, let me see it again. So each row is a ground truth. Each column is actually the prediction. So the ones on the diagonals of this confusion matrix are the ones we successfully predicted or correctly predicted. So let's compute the overall performance metrics. And the overall accuracy will be this value divided by the length of the y-test, which is about 87%. So doing this exercise actually tells us that because the performance on the training data is about 86%, and we didn't lose any accuracy after applying this model to the test. That means we're not overfitting the model. The model is good to use. And in this lesson, we created this training model, and we also saved the best model into a binary file. In the next lecture, I will show you how to serve this model into a web service. Stay tuned, and good job.